Okay, hello everyone. So what I did today was I read the third chapter of this book, NLP, Practical NLP, the text representation. So there was a concept of vector space model for simply converting the text into something like vector numbers or call it vector space. The basic vectorization approach is one of decoding we already know. The bag of words, think of it like a kept count of things. Anagrams is like one character, two character, three character, four character, and here is what is the number of characters you are dealing with. DF IDF was something interesting. Earlier we were giving equal weightage to the words, like however many words were given, we're simply giving the count of or not, is present or not. But in DF IDF things were changed. We give the importance to the word, like say the document. Let's say we have 1,000 research articles, and we want to just tag them. Which company is this or of. Let's say we find a document, we found that it's used IBM multiple times. So you can refer from that, like it may be related to IBM, or for this that document, IBM is important. Okay, so that is DFS down frequency and IDF is inverse document frequency. So we can go in detail later. And they become word embeddings. So this is there was very sparse kind of representation. So when we move to word embeddings, so the representative become very dense. Representation becomes okay, and the in embeddings they are also include the context, like for training the embeddings, like for the approach of C bow and skip gram. For word to vector we use neural networks, and here we sometimes give context to predict a word, and in the second we give the word to predict a context. So from there we can say like it encompasses the context. Okay, then we go went beyond the words and character. Okay, we are keeping a vector for the paragraph. Just and after that okay, we also visualize it. We use TSNE for that. Okay, so say the 100-dimensional space vector, and you just reduce it to a 2D or 3D to for a better visualization. And the handcrafted feature sorry, handcrafted feature representation. So basically, for some of our domain problems, just using some pre-trained embeddings won't be sufficient. So we develop our own features. Okay, and there are many use cases where we used hybrid, like the basic vectorization approach, embeddings, and also the handcrafted features. Okay, so after that, I went to like I was working on a project idea. So it's based on computer vision. So actually, it was kind of a productivity, we can say, tool. So which supports you like a deep focus, you can say. So the project idea is, yes, I am sitting in front of a laptop. So we'll use webcam to detect whether person is present or not. If it's present, good. Like we will want our webcam to keep track of when till the time or when the person is present. Basically, let's say you want to study for 3 hours continuous, so we can just input on a system 3 hours, so that the system will ensure that you will sit there. So let's say if you're going to leave, it will bring a notification or sound. Okay, get back. I go back to your work. So it is helpful for those persons like who believe that if they just for sit for more hours, let's say uh, we are currently facing that as a span problems. So let's say if I'm barely only able to focus 25, 30, 45 minutes. So, and my one setting is around 1 hour. But I strongly believe that if I sit for more hours, 1.5, 2 hours, 2.5 hours with a great focus, so my work efficiency or uh, the number of amount of work I can get it done will be better. So for those kind of people, we this project could be beneficial. So I will definitely make it for myself at least. Okay, after that, I went to study this lecture by Andres Karapati. It was great. Basically, here we have a bunch of uh, around 30,000 numbers, names basically, and using that names, he was generating few new names. So he basically used very basic model by he used bigram, one neural network also, these two approaches, and he got the same result using both two. And the explanation he has done is very great. So yeah, that's it for today.